Hi everyone. Okay, this is a video for lesson 22, session 2, and it is on page 464. We are continuing the fractions on a line plot lesson. And for this first problem, all you have to do is make a line plot, so that's nice. It says 10 students in Mrs. Holbrook's class are growing plants. One day they measure the heights of the plants in inches. The heights are shown below. Make a line plot to represent the data. Okay, and then here are all the heights of the plants. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different plants they measured. Oh, that makes sense. I guess there's 10 students, so each student has a plant. And then the smallest one is like, there's 1.5. 1 1/4 inches would be the smallest one, so I want to make sure that my number line starts at 1 is my smallest number. And then there's a lot of 1s and 2s, but there's no 3, so my biggest number over here will be 3. So it'll go from 1 to 3 on my line plot, my number line. Okay, so I'm gonna make it really long because I'm gonna break it up into eighths, because that's what the majority of the fractions are in, is eighths. So there's my number line, and I'm gonna have 1 right here, 3 on this end, and then in the middle between 1 and 3 is 2. Okay, and then I'm gonna cut it into eighths, remember? So I'll just do my tick marks first, and then I'll label them. So that's half, fourths, eighths. Okay, it's easier to do it like that than starting like right here and just 1, 2, 3, 4, 5, 6, 7, 8, 9, because you don't know if you're spacing them evenly. So I'll do that again and talk through it as a label between 2 and 3. So if you cut your number line between 2 and 3 right in half, then there's 2 even parts, so that's halves. If you cut between here and here in half, and then same thing between here and here, now it's even fourths. So then if you cut each fourth in half, then there's eighths. Okay, so my number line is cut very evenly into eighths, and now I just need to label them. So this was 1, so this is going to be 1 and 1/8. The next one's going to be 1 and 2/8, but I'm going to write the equivalent fractions too, because some of these are not in eighths, some of them are in fourths, some are in halves. So 1 and 2/8 is also 1 and 1/4. Remember equivalent fractions? 2/8 is the same as 1/4. So see, like this one right here, 1 and 1/4. That'll go right there. But anyway, first gotta continue labeling. So 1 and 3/8, 1 and 4/8, but 1 and 4/8 is equivalent to 1 and 1/2. 4/8 is equivalent to 1/2. And then I've got 1 and 5/8, 1 and 6/8, but that's equivalent to 1 and 3/4, 1 and 7/8, and then 2, and then 2 and 1/8, 2 and 2/8, which is equivalent to 2 and 1/4, 2 and 3/8, 2 and 4/8, which is equivalent to 2 and 1/2, 2 and 5/8, 2 and 6/8, which is equivalent to 2 and 3/4. Remember, you divide both sides by 2, and 2 and 7/8. Okay, so hopefully you made yours long enough. It's hard to fit all of that labeling in there nicely, so mine's a little bit smushed, but that's okay. All right, and then all I do, I'm gonna grab a different color, but I'm going to just make the X's above each fraction for when there's a plant there, okay? I guess I could label it. So this number line is for height. Remember, we wanna label the units, so I'm gonna say in parentheses, in inches. It's the height of the plants in inches. And the title of my line plot, I mean, you don't have to do this, but it's good. Plant heights. Okay. Then with my other color, you don't have to do different colors or anything. I just think it makes it easier to see. I'm going to go through and each one I'm going to find on my line plot, label it with an X, and then I'm going to cross it out in my list just to make sure I did that one. Okay. So first is 2.5. 2.5 is right here at 2 4/8. So I'm going to put an X. Then I'm going to cross that one out up here. Next is 1 7/8. Right there. And remember, we try to keep our X's the same size. And then another one at 1 7/8. 1 1/4, which is right there, the equivalent fraction to 1 2/8. 2 5/8. 2 1/8. 1 7/8 again. 1 1/2, which was equivalent to 1 4/8. 1 7/8 again. And 2 1/8 again. Okay, and then double check that you have 10 X's if you've gone through them all. 1 2 3 4 5 6 7 8 9 10. Okay, so I got all 10 plants. So the one that occurs most often is this 1 7/8 inch plant. Okay, so they didn't ask us any other questions about it. All we had to do was make and label a line plot. So that's it for that page. Pause it here if you need to catch up with your labels or with your X's. I'm turning the page. Okay, on the back, it just shows us a couple different ways to do it. Different model it. Here's the same problem. Model it. You can represent data values that are mixed numbers on a line plot. We know that because we just did it. So they just, they didn't label all their tick marks in between, but they started with a couple of the X's there. And then it says you can represent data values that are mixed numbers on a line plot with a number line divided into eighths and labeled. Yep, that's what we did. Okay, and then each X shows that there is a data point for that height. Okay, so let's move on to the connected questions on page 269. Right here. Okay. Number 1, look at the modelets. Why do the number lines go from 1 to 3? So why do they start at 1? Why do they go up to 3? And then why are the number lines divided into eighths? Well, the number lines go from 1 to 3 because all the plant heights are between 1 inch and 3 inches. Okay, there's none that are exactly 1 inch, there's none that are exactly 3 inches, but that's just a nice even range, right, to start it and end it. Okay, so nice centered. Can you see all the plant heights are between 1 and 3 inches. Okay, and then there's a second question. Why are the number lines divided into eighths? Most of the fractions they gave us were in eighths. That's also the largest denominator. Remember, they give it some of the, right here's the list again. Some of them have a denominator of 2, some have a denominator of 4, but the largest number denominator is 8. Because if it was in halves, if we just did 1, 1.5, 2, 2.5, 3, you know, then where would you have put 1 7/8? Okay. I'm going to just say most of the fractions are given in eighths. Most of the heights are given in eighths. I always think that word looks weird. I always think I spell it wrong. There's too many H's, right? Looks weird. Okay, number 2. Why are there 2 X's above one of the tick marks? That must mean that there are 2 plants at that height. All right, if there's 2 X's above one of the labels, it's 2 different plants that are the same height. There are 2 plants that are that height. Okay, number 3, plot the remaining data values to complete the plant heights line plot below. Well, that's rude. We already did this. Okay. So I'm just going to be looking over here at my list, but I can't show you both pages. So there's a 2 1/2. They already did that one. 1 7/8, 1 7/8. Okay, so they did the first 3 on their own, and then 1 1/4 right there. 2 5/8, 2 1/8, 1 7/8, 1 1/2, 1 7/8, and 2 1/8. 1 2 3 4 5 6 7 8 9 10. Yep. Okay, so that's all 10. I was just looking at the list on the previous page as I did that. Okay. Number 4, describe how to make a line plot with data that includes fractions. Okay, so let's just describe what we did. A little crooked there. Okay. First, you have to draw a number line. Okay. Then you divide it into equal parts based on the fractions. Let's see. Divide it into equal parts and label it. Okay. And then you mark X's above a number for each time it appears in the data. So every time in your list you have like 2 1/8, so you put an X above it. Okay. So mark an X above a number if it is in the data list, like the list of plant heights is the data list in this case. Okay. And then reflect. Which models, strategies do you like best for representing data on a line plot? I feel like there's only one way to do this. I don't really understand this part because this is exactly how it should look. There's no other way to make a line plot for this problem, you know? Like there's not a lot of different strategies or methods. Okay, so whatever you want to write, explain your favorite way. Oh my gosh. Okay, I'm gonna try not to panic, but there's a spider on the wall. If I don't post a second video after this one, it's because this giant spider in my office killed me during this video. Wish me luck. Okay, I need to continue. Reflect, whatever strategy you like, okay? Spider's getting closer. Not gonna panic. Okay. The apply it problems on page 470, the next page. Number 6, the data below show the length of leaves in inches that Jill collects. Complete the line plot to display the data. So here are her different lengths. There's 1, 2, 3, 4, 5, 6, 7, 8 different leaves, and they already created the line plot for us. They already labeled it. All we have to do is put in the X's, okay? So 2 1/2 is right here. Cross it out as you go. 2 1/4, 3 1/2, 2 3/4, 3 whole inches, 2 1/2, 2 1/2 again, and 3 again. 1, 2, 3, 4, 5, 6, 7, 8. Yep. That's it. Number 7. Al records the length of some fish in inches. Okay, and there's all his data. 1, 2, 3, 4, 5, 6, 7, 8, 9. Did I count that right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, 9 fish. Okay. And then we need to make a line plot. Okay, and everything is in eighths. So let's see, my lowest number, there's 9s. Okay, so I'm gonna go from 9 up to 11, okay? Because if I stop it just from 9 to 10, there's fractions that are over 10. See, like there's 10 and an eighth, so I need to go beyond 10. So I'm gonna start way over here. Okay, don't put it too low because you need a label below it, but don't put it too high on in your space because you have to put X's above it, right? So over here is gonna be my 9. Over here will be 11, and then right in the middle between those two is 10. Oh my gosh, I lost track of where the spider is. Pray for me. Okay, eighths. So remember, between 9 and 10, you cut it in half, cut that half in half, then cut each fourth in half. Perfect. Between 10 and 11, cut it in half, cut that half in half, oops, and then cut this side in half, and then cut each fourth in half. Oh man, so many distractions in this lesson. I can hear Mr. Flitton in the living room starting up Call of Duty. Did you guys know that about me, that I play video games? Some of you might have known that about me. Anyway, I'll try to focus on these fish that we're supposed to be recording. Okay, so I need to label these. 9 and 1/8. Write your labels small because it's hard to fit them in nicely. 9 and 5/8, 9 and 6/8, 9 and 7/8, and then 9 and 8/8 would be 10. Okay, this is going to be even harder because 10 is a two-digit number. 10 and 1/8, 10 and 2/8, 10 and 4/8. I don't have to worry about equivalent fractions in this one because they're all provided to me in eighths. 10 and 7/8. I don't know what day you guys are watching this on, but it is Memorial Day today, so I hope you guys are having a great Monday off from schoolwork if you parents respected the holiday and didn't make you do schoolwork today. Normally you would have a day off from going to school if school's open. So, okay, my line plot is made. It's not very cute because it is very squish. It looks a bit crammed. I forgot to label it though. This is length of fish, so I'm going to say length. And it was in inches, it told me. We always want to tell them the unit because what if these were feet? 9 and 10-foot fish. That'd be scary. Okay. Now I need to go and mark X's for every number that appears in the data. So 9 and 2/8 is first. And then I cross it off in my list. 10 and 4/8, 10 and 5/8, 9 and 6/8, 9 and 7/8, 10, 10 and 1/8, 9 and 6/8, again, 10 and 3/8. Okay, so there's only one measurement that had 2 fish. There were 2 fish that were the same measurement. That's a better way to say that. And that's it for that problem. So number 8 on the bottom. The length in feet of some pieces of wood are shown below. Fix the line plot at the right to correctly show the data. 1, 1.5, 2, 1 3/4, 1.5, and 2. And then they did it right here. There's 1, 2, 3, 4, 5, 6. I only see 5 X's. So 1, they got that one. 1.5, there's 1 X there. 2, yep. 1 3/4. Okay, they don't have one at 1 3/4. 1.5, there's the second one, and 2. So they were just missing that 1 3/4 right there. So just add your X above 1 3/4, and then that's it. Okay, and then there are, let me move all my pens. The green practice pages, just front and back right here. Okay, so the example problem is already done. They gave you a table with some data about butterfly wingspan, and then they already labeled all 6 of those data points in the line plot, so we're good there. So this problem goes with number 1. Okay, the height of 4th graders is measured on the first day of school and on the last day of school. The growth in inches of some students is below. That's cool. I wish I would have measured your guys' heights at the beginning of school. I bet a lot of you guys have grown. Some of you are taller than me now. It's scary. Okay, so this is not their height in inches, right? No one is 3 inches tall. This is how much they grew between the first day of school and the last day of school. So somebody grew 3 inches, somebody is 1 6/8, and so on. Okay, so there's 1, 2, 3, 4, 5, 6 different students that are measuring their growth. So they already labeled this, they already have it all ready to go. We just have to mark our X's. So 3 inches first, right there, and then cross it out. 1 6/8 right here, 2 2/8, 1 4/8, 2 2/8 again. 2 students grew the same amount, and 2 7/8. Okay, that's all you do. Back page, and then we're done. Okay, oh, that's cute. That's adorable. Okay, Micah's dog has 8 puppies. The length in inches of each puppy is listed below. So they're short little puppies, guys. 4 inches is like that big. Tiny puppies. Okay. In a line plot, which value will have 3 X's above it? So imagine the line plot. Which number do you see 3 times? 4 1/2, 4 1/2, 4 1/2. 4 1/2 would have 3 X's above it in the line plot, right? 4 1/2. Okay, could a line plot with a number line from 5 to 6 be used to represent the data? Explain. So, for example, if your number line started at 5 and went just to 6, would that be a good way to represent the data? This data? Well, no, because all of these are between 4 and 5. Where would you put 4 1/2 on this? Okay, that would be over here. It's off the number line. So, no, because all of the data is between 4 and 5. Okay, and then draw a line plot to represent the data. All right, so I'm gonna make a line plot that goes from 4 to 5. Hi, Luna. That heavy breathing is not me, it's my dog. 4 on this side, 5 on this side. And I'm gonna break it up into fourths because a lot of the fractions in the data are in fourths, and this 4 1/2 I can still show with fourths, right? So in the middle is gonna be the 4 1/2, and then in between be 4 1/4 because this is different color. 4 2/4 right here, same thing. And in between 4 1/2 and 5 would be 4 3/4. Okay, so next color, my label, this was length of puppies in inches. All right, stop groaning, Luna. She hates math. Okay, so now I need to go through my data, crossing off as I go. So 4, right there. 4 3/4, 4 1/2, 4 1/2, 4 1/2. 4 3/4 again, 4 1/4, and 4. Okay, so no puppies were 5 inches. Number 5 down here, all these questions are about our number line that we just did, our line plot. Same thing, number line, line plot. Line plot just has the X's above it to show your data, right? Okay, use the line plot to answer the questions. How many measurements are recorded? So how many X's do you have, or how many puppy lengths were in the data? So 1, 2, 3, 4, 5, 6, 7, 8. Let me double check. 1, 2, 3, 4, 5, 6, 7, 8. Yep. 8. What's the longest length of a puppy? So it doesn't go, there's no 5-inch puppies, so this one, 4 3/4 would be the longest. There were 2 puppies at that length, but it doesn't ask. What's the shortest length? 4. I'm gonna label these inches just so they don't think it's a 4-foot long puppy. How many puppies are less than or equal to 4.5 inches in length? So here's 4.5. How many are equal to or less than? So all these X's. 1, 2, 3, 4, 5, 6. How many puppies are greater than 4.5 inches? So not these ones, greater than, there's only 2. All right, and that's everything for this lesson. That was a pretty quick one, right? Next, we will work on line plots again, but we're going to be using our knowledge of adding mixed numbers in that lesson. See you guys then. Bye.